Hello again. In this session, we will discuss speed and velocity. So let's start with speed. You've heard about speed a lot of times. But what is speed? What are we trying to measure by measuring speed? Speed, we know, is a measure of fastness, which basically tells us how fast something is moving. So how do we measure how fast something is moving? We know this instinctively that something which is moving fast covers more distance in less time. We know that if something is moving faster, then in the same time it would cover more distance. So if you think about it, while talking about speed or thinking about fastness, what we essentially think of is how much distance is covered in a given time. For that reason, we've defined speed as distance by time. So, speed is the distance covered by the time taken to cover that distance. Now, whenever you see a quantity defined as, let's say, y is equal to x by t, then we can say that y is rate of change of x with respect to time, which means that y is basically a measure of how x changes in every second. On the same lines, this speed can be said to be the rate of change of distance. Let me explain this. Now, from the very definition, we see that if a particle going from A to B covers 100 meters in, say, a time of 10 seconds, we can tell that its speed is 100 divided by 10, which is 10. So let's first briefly focus on its units. We know that distance is measured in meters or kilometers, right? And time is measured in seconds. So, in the standard units, we take distance in meters and time in seconds. So, the units for speed are meter per second. So, the speed of this particle is 10 meter per second. Right. So, this is simple enough. I'm sure you've followed it so far. That speed is distance by time, and using the same formula, we get that the speed of this particle is 10 meter per second. Now, coming to this interpretation, what this tells us is that this particle covers 10 meters in every second, and hence we are calling it rate of change of distance. It is the rate at which distance is being covered. This is what speed is. This is what gives us the idea of fastness. That is how much distance it covers every second. Right. Now, when we are calculating speed, we are not talking about directions. So it is obvious that speed is a scalar quantity. Now, the vector counterpart of the scalar is called velocity. So velocity is basically speed when you attach direction with it. Now, just like speed is defined as distance by time, velocity is equal to displacement divided by time. Now, let's take an example to understand this better. Let's say, extending this case, it is given that the particle after reaching B comes back to point C and it takes an additional 5 seconds. So, the problem now is that a particle goes from point A to B, then comes back to C, and it takes a total time of 15 seconds. For this problem, we wish to find, let's find everything. Let's find the distance, the displacement, the speed, and velocity. So for the first part, which is the distance, I'm sure you figured Distance is the total length of path, and hence it is 100 plus 50 since C is the midpoint. So the distance covered is 150 meters. 100 plus 50 gives you 150 meters. Right. Next, for displacement we need the distance between, the shortest distance between the initial and the final position. So displacement is nothing but the length of AC, which we know is 50 meters. And hence the displacement is 50 meters. Right. Next, let's come to speed. Speed we know is the distance traveled by the time taken. The distance traveled we've calculated is 150 meters. Hence, its speed is 150 divided by the time, which is 15 seconds. Hence, this gives us 10 meter per second. So this is the value of speed. Right. Next, let's come to velocity. For velocity, we need displacement, which we have found to be 50 meters. And hence, the velocity would be equal to, let's not put the sign yet because we're not treating this like a vector. So let's first find out magnitude, then we will discuss the sign. So for magnitude, we see that displacement is 50 meters divided by the total time taken is 15 seconds, which gives you a value of 3.33 meter per second. So during this journey, the particle was moving with a speed of 10 meter per second, but its velocity for this journey is only 3.33 meter per second. Right. So I hope you see the difference between speed and velocity. When measuring speed, we look at the distance covered, whereas while measuring velocity, we will look at displacement. Right. Now, let's think of velocity as a vector. Since we know velocity is displacement by time and displacement itself is a vector. Right. So let's first find the direction of displacement in this question. You know that displacement has the direction which points from the initial position to the final position. And so the displacement is shown by this vector AC. And the direction of this arrow is basically the displacement. Now, when you divide a vector by a scalar, the magnitude changes but the direction remains the same. Time, I'm sure you figured, is a scalar quantity because there really is no sense in attributing direction to time, is there? Right, so time is a scalar quantity. So displacement by time gives us another vector which is velocity, and it will have the same direction as displacement. Right. So since displacement points from A to C, the velocity vector also points from A towards C and has the magnitude 3.33 meter per second. Right. If you remember, we had said for substituting values in equations, we must have a sign convention. For that, let's decide a direction which we are going to call positive. Now, just for the cause of explaining to you, let me take this direction as positive. If I do that, I hope you can see that the displacement AC actually is in the direction opposite to the direction we have taken as positive. And hence, when you want to write V as a vector, you will have to write the displacement as minus 50. So now it is correct to write V as a vector because now we are substituting values with sign. Right. So V becomes minus 50 divided by the time taken, which is 15, and so we get that velocity as a vector is equal to minus 3.33 meter per second. So we understand that speed is a scalar and simply equal to distance by time, and velocity is a vector quantity is given by displacement by time, and it points in the same direction as displacement. Now let's look at an example to understand the idea of speed even better. Let's say that a particle starts from point A. In the first 10 seconds, it goes up to a point B, which is at a distance of, let's say, 200 meters. Then from point B, in the next 10 seconds, it manages to reach a point C, which is at a distance of 300 meters. And then from C, it moves another 100 meters to reach a point D in the next 10 seconds. So in each of these intervals, the time taken is 10 seconds. Right. So we are interested in finding the speed of this particle in each of these intervals. Right. I'm sure you can do it very easily. The speed in this interval AB is the distance in AB divided by the time taken to move from A to B, which is simply 200 by 10 and hence 20 meter per second. On the similar lines, if we wish to find VBC, it would be equal to 300 divided by 10, which is 30 meters per second. For CD, you would have 100 divided by 10, which gives you 10 meter per second. Now, if you were to find the speed in the interval A to D, what would that be? That would be 200 plus 300 plus 100, because that would be the total distance covered, right? And speed is distance covered by time taken. So, when you have multiple intervals like this, the speed would be calculated by finding the total distance, which in this case is 600 meters. This is to be divided by the total time taken, which you can clearly see is 10 plus 10 plus 10, which is 30 seconds. Right. So, 600 divided by 30, that gives you 20 meter per second. Right. So, what is the speed? Think about it. The speed says 20 meter per second, but only during the first 10 seconds was it moving with 20 meter per second. Now, it so happens that in this case, we are getting a value which is similar, but it might so happen, like for instance, if our question was only from B to D, that is, the particle had only gone from B to D, you know that distance is 300 and 100, the times were 10 and 10. So, if you find the speed for this interval, it would be 400 divided by 20, which is again 20 meter per second. But in the interval B to C, the speed is 30, and in C to D, the speed is 10 meter per second. So, the speed in this interval was never there, right? It was never moving at 20 meter per second. So, the question arises, what does 20 meter per second represent? So, it basically represents the average value of speed over that interval. So, we can define that average speed over such multiple intervals is equal to total distance. The total distance covered by the total time taken. So, whenever you have multiple intervals like this, we can find the average speed as the total distance covered by the total time taken to cover this distance. Right. Now, as opposite to average speed, there is a quantity which is known as instantaneous speed. So, instantaneous speed is the speed at a particular time interval. For example, the speedometer on a vehicle shows the instantaneous speed, right? Because it shows you the speed of your vehicle right at that very time instance. Such a speed is called instantaneous speed. Now, to measure instantaneous speed, you actually need to measure very small intervals. You need to measure the very small interval covered, the very small distance covered in a very small fraction of time, and then that fraction will give you the instantaneous speed. So let me explain a few things here. This delta basically is shown to symbolize change. So this is delta x, which shows change in position. But as I've said, this delta x is very small because we want to measure the speed at a very specific time. And for the same reason, delta t is also very small. Now, how does this help? Look at this example to understand this. The bigger the interval, the more the variation in speed, because you cannot be sure that the speed is maintained. So as you keep making the interval smaller, you can be sure that you are measuring the value of speed which is being maintained at this very instance, right? So to find instantaneous speed, we need to measure it over a very small interval, right? So if you think about it, whenever we measure speed as distance by time, we are basically measuring average speed. We are measuring the average of speed in that interval, right? So for now, we need not worry much about instantaneous speed. For the cases we will consider, the average speed would be the speed in that interval, right? Let's now look at another example. So let's say a particle moves such that for the first 10 seconds, it moves at a speed of 10 meter per second. For the next 20 seconds, it moves at a speed of 20 meter per second. And for the last, let's say 20 seconds, it moves at 15 meter per second. So for this case, we wish to find the average speed of this particle as it goes from A to D. Now, in such a question, the mistake that is often made is that to find the average speed, you would find the average of the speeds, right? There's a tendency to do this, that is to find the average of the speeds. Now this is wrong. This is because we are trying to find the average rate at which distance is covered. So hear this out. This is a tricky sentence. So what we are trying to find is the average rate at which distance is covered and not the average of the rate of distance covered. Try to figure that sentence out. Meanwhile, this is wrong, and the correct way to find average speed would be the total distance traveled divided by the total time taken. So we are using the same formula. I've only broken it down into 3 parts, right? So the total distance is sum of the distance covered in each of these intervals, and the time taken is sum of time taken in each of these intervals, right? So the total distance becomes 10 into 10, which is 100 meters, plus 20 into 20 becomes 400 meters, plus in the last interval 15 into 20 gives you 300. So this is the total distance traveled, which is clearly 800 meters. Now let's focus on the denominator. You have 10 plus 20 plus 20, which basically gives you 50. So 800 divided by 50 gives you 16 meter per second. So the average speed, the average rate at which distance was being covered is 16 meter per second. And mind this, that average speed is not the average of the speeds. Had you done this, you would have gotten 45 by 3, which is 15 meter per second. Now this would have been the average of rate of covering distance, but we need the average rate, right? So I hope with this you have a clear idea of speed and velocity. In the next session, we will talk about acceleration.